Afternoon, everyone, or good morning, depending where you are. We're going to start with Rust fundamentals. Rust is a very new language and it's very big, so I'm not going to be covering every single aspect of Rust, but I'm going to try to focus in on what's important for offensive professionals, both offensive and defensive perspectives, and kind of hope to inspire. My end goal here is to inspire people to start looking at the language and start maybe programming if you're a developer. So, what we're going to kind of start to talk about here is obviously what is Rust, why should we care, and then kind of break it down into the more important parts. How does it work? The package system, the actual code, and then kind of as we kind of get near the end, talk about some features that I personally like. I think they're valuable, and then some resources I've kind of curated for everyone to kind of get started, or if you want to start looking into this after this webcast. So, what is Rust? Um, if you've heard me or if you follow me on any social media, you've seen me in the past year or so kind of really talk a lot about Rust and just the passion I have towards it because I've recently fallen in love with this language. And yes, I just can't stop talking about it. But if you're unaware, it's a very low level, system level oriented programming language. And then what that means is that it can have access and manipulate hardware or low level instructions. But it offers it at a very high level and very easy way to ingest, making it very user friendly. And that was a big selling point to myself and for others. And I'm going to kind of reiterate that they've made things easy throughout this whole talk. So please bear with me on that statement. It does ring true in so many different points. But from a more technical standpoint, Rust offers great performance, safety, and memory management. Those are some really key things, especially when you look at some other languages that sometimes they lack. Um, so when we kind of look further into Rust, I kind of say like, well, obviously everyone has some kind of background. What does it seem similar to? And I actually kind of like to say it's honestly like a blend of three. So if you have any background or experience programming Golang, C, C++, or Python, you're going to see a lot of similarities and or see something familiar. And kind of that was a great way for me to kind of learn and kind of jump into this language pretty fast. As I came from a background of programming in Golang and Python, so I started seeing similarities and things that were very familiar right off the bat, and that kind of just made this transition really easy. It's really multi-purpose, from low-level payload, C2, back-end stuff, front-end. There are packages, information, and the ability to do pretty much anything. I haven't actually seen like a Rust or a programming project that Rust can't tackle. For a language that's been recently kind of taken off, it's quite impressive to see the wide range of packages and libraries kind of being created. One of the other things that I really like, and I'll talk more about this, is their built-in dependency manager. I think coming from once again a language of background of Python and Go, where you have to download all the package and stuff, their cargo functionality really has changed the game for me. It allows me to kind of develop or move anywhere. To the fact I actually have an iPad right here that connects to a VM, tiny little VM that's really a Docker container, and I'm able to program on the go if, say, I'm an airport and I have an idea or something like that. It's how fast and easy it is. I don't have to have a big setup or even just like a large VM of libraries. So why should we care? Like, why should we care about another language? Well, as of the last year or so, Rust has really kind of taken the world by storm in the sense of adaptation. Um, Rust has been slowly been integrated into Linux and Windows kernel, and is slowly going to. The kind of an idea here is to phase out a bit more C and add more features and functionality that obviously C kind of just wasn't providing, as well as the ability to use ARM, all these other MIPS languages. Rust is kind of just becoming this talked about and kind of migrated to type language. And so this is just a great example. If you punch anything in, you can kind of see all these great articles throughout the past year about how Windows 11. So I think now it's like the latest version. It comes with a Rust-based kernel. Same thing with Linux. I think multiple different instances or flavors of Linux now are running on Rust. So it's here. It's everywhere pretty much. So starting to learn about it and talk about it is a very vital point, especially from a defensive perspective. What new security flaws or pitfalls or things that we need to be aware of from that side? From an offensive, what does this mean? Are there things we should be looking into? If you're interested in exploit development or even just developing, tools, this is, a giant new uncharted land of potential opportunities. So, from a more technical side, Rust. When you look at Rust and you compare it to those three languages, it's a lot smaller and faster. The code is really, lean. It's compiled natively. Um, One of the big things, I was a big Go programmer. A lot of my tools as of recently were Go. I kind of decided to kind of move fully into Rust because of a lot of things like there's no garbage collector. If you're not familiar with Go or any of the garbage collector, that's just a functionality that Go has for memory management. So that way there is no leaks or other security related issues or even a crash. But because it does bring its own collector and manages that, those files are really big. If you've seen, there's a lot of jokes online about, Go being really thick packages or big things, or they consume your whole hard drive, so to speak. So Rust kind of handles that memory for you, same way, but without needing a garbage collector. And it's really, based on its ownership, which we will cover. There's a lot of safety features to ensure that when you do compile, you don't have any dangling pointers, uninitialized memory, any type of vectors. So your code is really secure. You're not going to be leaving those traditional type of vulnerabilities that could be fuzzed, as well as having that multi-threaded capability. So there's a lot of different things that are balanced while still maintaining that speed. Such that, when you look at the benchmarks of other languages, you can see that per second, the amount of data or packets in HTTP's case it can handle is just quite impressive. Um, Kind of leave this here for a second to kind of go through, but when you look at all the different languages that are kind of called fast, Rust is either beating them or keeping up with them while still having all these capabilities. So there's definitely a lot of things there. If you're someone that does a lot of development, or even if you're writing your own C2, for instance, or anything else like that, I would say definitely look at Rust for performance. Which kind of leads me into our next point. Went too far, sorry. From an offensive professional, what are some enticing points? Well, first off, the library support. Definitely something that you see a lot with Python when we went from Python 2 to Python 3, making sure all those dependencies are there and libraries that you were using previously. Because that could be a problem, especially if you're performing tests or any type of penetration gig, where if you don't have your right tools and you're spending half the time trying to fix them, you have to download to this virtual environment, you got to set this up, you have to compile this, you have to do all these different things. Um, it does bear down a lot of time. Rust really has looked at that and kind of made sure that their libraries are all compatible on OS X, Linux, Windows, and made sure that there's a large swath of different options and capabilities. Um, it like I said before, it's multi-purpose. It allows for any type of development. If you're someone that does a lot of web app stuff, there's tons of great stuff for that. Low level kernel stuff, network stuff, packet intercepting, front end dev, anything like that. What I really like, and this is the number three bullet, I always come back to, if you ever had a conversation with me, I know several people here, unfortunately, I've talked their ear off about it, is their LLVM, or low level virtual machine capability, which allows to take that code and turn it into machine op code really quickly and effectively. And because of this, just natively, that this is a component of Rust, it makes it a really good candidate for not only bypassing AV EDRs, but also for static reverse engineering protections. So that way, if you are doing some type of red team engagement, you don't want your new proprietary technique or some kind of code to be kind of easily accessed and then published on VirusTotal. There's a lot of great ways to protect it from being reverse engineered. It's not perfect, but it does do a great way of avoiding those static detections as well as Yara rules, as well as the native cross compatibility. I mean, there are tons of resources for compiling on Windows to OS X to Linux. I mean, I myself write a lot of my stuff, like I just mentioned, Linux, and I work constantly off OS X. But all the tools and everything I develop are for Windows, and I've never had any issues. The compatibility, the speed, the performance is great, and that's something that sometimes other languages struggle with. And that's why I keep on going back to the ease that they did when developing this. It's really great. It's really focused on the authors, developers, not some kind of hierarchical language where you have to go to university and have a series of expensive tools just to be able to program. They want you to be able to get and go with minimal problems. So much so that they made it so easy to actually install. You can go to the rustlang.org site, or you could just use what they provide right on their front page is this curl command. Within two commands, where you want to put this, your native home drive, it does all the work for you, and you have everything set up. That's how easy it is. So, once again, another point for just ease of use, especially, I'm sure anyone here who's done any development as a side part of their job realize that, you don't want to spend a lot of time setting up an environment, getting everything right. You just want to be able to code and do what you need to do. So it's very important, and that to have that kind of ease of use and flexibility. Um, it actually creates when you install Rust. It doesn't just install the language. It actually provides you a lot of quality of life features. Um, so much so that we'll kind of go through them just at a very high level. You can spend a whole day talking through the different options and stuff. But I encourage anyone who's wants to kind of look into Rust further to look at these with a very fine tooth comb because it will make your life easier. But the first one is Rust Up. So it's part of the entire package, but its only job here is to manage your compiler and different versions of it. The standard, stable, beta, and nightly. Why do we have multiple different versions? Because new features are constantly being added. Nightly versus stable, there are certain things that are part of the process or OS that it doesn't allow because it's, like I said at the beginning, safe and good memory management. Sometimes you just need to, take off the safety features and just go hog wild. So they provide that access. Um, as new versions come, if there's new development package dependencies and stuff, you can read through it. You can see, hey, based on the output, if you compile a program that says, hey, we feel that better optimization would be in this new stable version. Would you like to try to compile it in this? So it provides all those things for you right there at the click of the button. But it also gives you access to two very important subfunctions, Rust FMT and Clippy. Now, before anyone gets excited, no, they did not bring the Clippy with an icon. I really wish they did, but alas, if you just picture it in your mind, it still works. So, Rust FMT. I'm sure everyone here who's written code at some point has published and realized, ooh, I'm not following the standard formatting. Ooh, it's hard to read now for someone else. You don't need to format it yourself. You just run the FMT command and it will align all the imports properly. It does everything. It cleans it all up so that way it's per the industry standard and makes it easier to read just by a click. So you can write it however way you want it and they do it all for you. Next up is Clippy. So Clippy is probably one of the most powerful features of Rust in the compiler. And what it does is it performs static analysis of your code as it's being compiled and says, hey, there's some things we recommend you improve on here. There's things that could cause some problems. But it also checks your code and performs debugging and almost provides a pseudo IDE in a command line. So it will say like, hey, this line is broken because this variable is pointing to a null. How do you fix this? Well, we say that if you change this code line to be this, it will resolve it. Or hey, you're missing an import. So it's really, really good that way to troubleshoot your own code. And if there's other issues, they actually provide links to documents to read. Please see, Rust issue 4567 here, and you can go read about what the error was. Next up is the cargo package. So I mentioned before about those libraries. So the cargo package is an extension of that. It allows you to create, build packages and projects. It will set up the whole hierarchy for you. But it also ensures that when you're done, you can actually then turn it into a library that other people can use. So you don't have to worry and make sure that you're up to the standards again. It does it all for you. So you code, they do the work for you to make it accessible. So talked a little bit about that. Let's actually kind of talk about the libraries and the packages. So with Rust, they call it crates. I know it's not libraries or anything else, but that's really what they're called. And these are obviously groups of either struts, functions, you name it, that are used for executable code. It's designed in a way to be really modular and thus reusable. It also provides versioning, so if you have something that's dependent on a certain version and the new versions don't work, you can easily just call a different version without any type of weird type of modulation or modifying your code or custom things you have to then add in. All crates and stuff are at crates.io, so you can actually just search like, hey, I need something for web apps or something for TCP. You can then find all the crates. You can see they provide links, feedback, even people's reviews, and you name it. So it's really focused on the community. But inside those crates are modules. Modules, as I mentioned, can be functions, types, anything else, you name it. But it's really important is how they organize the code. This code is organized into a way that has submodules and then nested functions. I know that sounds kind of weird, and it was weird to me, but we'll kind of show an example. Considering that we're all kind of focused on Infosec, I thought I'd chose the Win API modules. So under I don't know why it's called just have to assume that someone who developed this had some kind of weird sense of humor. But under there, you have a series of different modules. You have process thread APIs, so that's any APIs for process threads. You have the Windows base for basic Windows APIs, and you have WinNT. Those are NT types or structs or constants. Sorry, and then memory APIs for the core module. So that's how they break it down. So that way, it's easy to kind of see, organize, and if you need something, you don't have to go look through an entire crate. You can just be like, I need it from here, here, and it's this module. And how it kind of looks is like this. So if you were looking for virtual allocate, you can kind of see right here. It's the module, sorry, the crate, then the module, the submodule, and then you find the function. So when you're looking for these things, that's great. But what's also really powerful is you can just import this straight up function. You don't need to import the entire library, the entire submodules, you name it. You can just have this one function that makes your code really light when you compile it. And as well, more documentation. So when we look at things, there's a great site called doc.rs that's supported and managed by the Rust community. And every type of crate that's certified is up there. So there's documentation on like, hey, this function, here's all the variables it needs, the dependencies, the types, any documentation. So if you're looking, you're trying to figure out things, there's all the information you need right there in one spot. So what happens when you have a package and you need multiple things and those submodules can get a little kind of crazy to kind of manage? Don't worry, they've thought of that. So what they have is this cargo file, which defines all your packages, dependencies, even compiler options. It helps you manage and organize everything so that way your project is very lean. You don't have any additional dangling sort of issues. But what's also really great is when we talk about this cargo.toml file, this file is read first by the compiler and says, hey, I need all these packages. Well, let's go download them for you. You don't worry about having to have them on your system. We'll take care of it. Just make sure your toml file is accurate. And it does all that work for you. Once it downloads it, then it compiles, bam, cleans itself up. So, oh, sorry, we can't go a little too far. We can't go anywhere without talking about how they would look in your code. So as those different modules, you can kind of see right here in this example, we have 3 uses of the crate std standard. So we're going to call the module env, then fs, then io. Then in there we have just 3 functions we need: file, write, and read. So putting them at the top, breaking them down like this seems like there might be a large list of dependencies, but this is actually a way to kind of keep your code clean and maintained. And what this looks like, going back to that toml file, as we can kind of see right here, this is an example of a tool. You can see we have libc, WinAPI, rad, and NTP. We have the version that we're going to use, and then under it we have that features equals, and we can see which submodules we're going to be bringing in. So this really allows us to keep it lean by just focusing on and defining what we need. We also can provide a lot of other information, such as the compilation flags. So if there's anything you want to do to manipulate how your file looks, maybe you want to not have an exe or a Linux executable, you want to have a DLL, You want to include your authors, notes, your attributes, the edition, the version, anything else like that. It allows you to do that all in one package. And we're using this TOML file. So it really keeps everything nice and neat and organized, which sometimes for me is a blessing because I'm not always that organized when I'm coding. I'm furiously typing away, completely dead to the world. So having something that is managing and organizing all my dependency, all my work is like having a second person there working with me. So let's kind of talk about that code for a second. As I mentioned, that cargo command comes into play. So if we do cargo new, we'll see the creation of our whole project called hello. There's the TOML file we just talked about, a folder called source with main.rs, and some code in there. That's all done by Rust. So we don't have to make sure that we don't have to worry about any of that stuff. It's just done it for us. Once again, Rust makes everything easier, so you just have to focus in on programming. As we kind of look at some of the features now, this is where we get into more of the technical stuff. So one of the things I always like to talk about is ownership versus borrowing. When we look at Rust code, everything from a variable, string, there's an owner. And there's ownership. Now that ownership can be transferred between other objects. It's not dependent. But why we were talking about this right now is because we make sure that no duplications can occur. If there is, Rust will remove it. So there is 100% ensuring that something else is deallocating its memory. This helps avoid any leaks and ensure that our code, our compiled exe or DLL or whatever, is leak-free, if you will. It's more secure. So in this example I kind of show, we have the string hello stored in S1. If we move it to S2, S1 no longer is valid. So if we tried to print it, we'd have an error at the compiler. Before the file even gets completed, the compiler will go, hey, wait a second, stop, there's a problem. We need to fix this line. And then if we do an actual print statement with S2, it will work. And if you're also interested how it handles variables when you're printing it is whatever you define, just with some curly brackets. So you can have two sets of curly brackets and put the order of S1 or S2 or whatever variables, but in that order. So it makes things really simple and easy to understand and follow. I've talked a lot about memory management and everything that's safe. So I thought it'd be a great opportunity to look at what's not safe. Especially this is very important for us security practitioners when we think of unsafe or mischievous ideas. So a lot of times when we talk about safe, everything is locked down. There's protections on the memory and everything else to ensure that there's no issues or guarantees what they call Rust code safetiness. But you can easily turn that off by just putting the unsafe flag in your code. Literally unsafe, open bracket, put your code in. And that allows you to access a series of things that are typically protected or blocked against. They include, accessing raw pointers, manipulating memory, and accessing data across multiple different threads. All the things you would want to do if you were, say, writing shellcode or a payload tool or something like that. You want to have all those access, and they provide it to you. Just you got to add an extra sentence of unsafe. And when you compile it, the compiler goes, wait a second, okay, turn off this flag for this section, okay? Turn it back on for the rest of it. So you don't have to make sure that your entire package is unsafe, just one function or one section of your code. And that's how they handle it. So it's really, really a very powerful tool that's often really not discussed. So I thought it would be advantageous to look at it and kind of bring it up here. Obviously, when you should use it. So I kind of just alluded to payloads and stuff, but any type of low-level controls or memory performance, it can allow you to getting access to it. As a result, you can create some really interesting things. There's been some recent packages around creating your own rootkit, drivers even, you name it, because of these unsafe flags. And there's a lot of great resources, information about doing this, but where I wanted to kind of focus in on is that this is a very powerful tool to kind of give you additional features. It's almost like getting the full access to the engine of a car, like a race car. You don't just take it to get groceries, you can take it on the track as well, so there's multi-purpose. Another great feature of Rust are its attributes. I would almost say that the attributes are more powerful than the actual unsafe flag we just talked about, because it actually provides a lot of features to manipulate things at the compile time or just even in your code for a line of code, an entire module, or a package. Um, these things can include like visibility. I often use it when I create a framework. So if you want to have like a console mode for a EDR bypass, or you want to move it in the background, with the control visibility, you take those print statements out. So when it compiles, it says, wait a second, this flag is on. Okay, we're going to rip this line out, this line out, this line out. Code still compiles perfectly. Just one little tag and it's removed. And if you want to see those lines, it just leaves them there. There's other things you can do, such as access low-level parts of a process, like the stack call or anything else like that. That's really big right now with focusing on evasion, is getting access to do stack spoofing, custom sleeps, return addresses, ROP chains, you name it. Even these flags even provide the ability to modify the compiling behavior. So if you want to strip out the debug or the panic mode, you name it, it gives you complete access. And what we'll talk about in the next slide is these metadata attributes allow you to actually also provide access to other languages from Rust, which is kind of cool. So the first language that it can give access to is C. Specified, you just do external C. And this gives Rust the ability to call C functions or conventions and vice versa. So we can pass arguments to C code or receive or listen without there being a lot of additional kind of compilation or any type of dependency issues. And when would this ever really come into play? My personal thing that allows this to happen is when we're talking about compiling DLLs. Obviously, when you're compiling a DLL in a different language, trying to use it on a Windows machine or a Linux machine, you're going to have problems because that operating system is written and expecting certain type of language and a certain set of flags and functionalities. Don't worry, Rust has thought of all of this for C. So using a combination of those attributes, we can say, first off, no mangle. What that means is when the compiler compiles this, is to say, whatever's right below me, I need you not to mangle it. It needs to be easily read so that way a function can call my name clearly. And then the public C declares that this function needs to be accessible. So I have an example of what that looks like. So on the very far left, we have our Rust code. And we see two export functions, cpl-applet and run. They both call the function main. In our TOML file, we have this bottom part where it says lib crate type, and that defines that we're going to be compiling a DLL. Since we have that no mangle and external C, when we compile this DLL, if we look at it in CFF Explorer, which is a PE parser tool that allows you to dissect and look at a file, see the attributes, all the different functions, where the headers are, all that information of any type of compiled executable, we can see under the export directory two clear function names, cpl-applet and run. We can see their address and everything else. So that means that if we can see it, any other program can, which means programs like run DLL, they can see it too. Another great one, which I thought was really cool, and I know that there's several people that here are probably going, what? Is external Python. Using the package pyo3, we have the ability to actually integrate Rust and Python together. This allows us to access the Python interpreter and even import Python code into a Rust application. We can call functions, scripts, you name it. And this kind of opens up the door for any type of possibilities. So essentially, we can take Rust, put Python code, like, maybe the Packit tool suite. I'm throwing ideas out of big tools, or another great tool, Pre2K, if you're familiar, and wrap it in Rust. So here's a kind of an example of what that would look like. We have our packages. We set it up so that way, our py results, because we're reading from another interpreter, we have to get that. So those are all the dependencies. And once we have that all, we initiate the Python interpreter. We can then, as you see on line 7, import sys, just like Python. Get version, you name it. All those Python commands come back to us in Rust. So I kind of compiled it and kind of show what that example looks like. You kind of see we can read the Python version. We can see the path, you name it. So this is something that's often, when you look at Python, Python's always had some dependency issues and stuff. But being able to bring it into another language is quite cool and kind of opens up the possibilities for like, interpreter and interpreter, that layered inception approach for offensive security. As for defense, that's going to be a hard one. I don't have an answer for you. I apologize. Another personal package or feature I love is the lit crit ability that is offered by Rust. So this package allows us to take strings, if you want to have strings, and XOR them. Why are we doing this? To make it harder for any type of static analysis tools to kind of read them. I will tell you many times, there have been times where I've been burned because in some of my tools I've developed or tools I've used by others, there are strings and there are YAR rules that have detected them because of those strings. So this lit crypt gives you the ability to compile these strings and hide them. So that way when they're only ever viewed is when they're executed in memory. This is an amazing OpSec feature. Um, this is great. When would you ever use this? I would say, if you ever had a payload you made, you drop it to disk, Windows Defender or the EDR instantly catches it before you even run it. That's because there's some kind of static string in your compiled tool that they're looking for and they caught it. So this helps eliminate that. And we can kind of see this. I wanted to show an example. I tried to show an example for all of these. But if we see here on the very left, we have two lines. And when we compile it, we can just simply grep that compiled file and we can see both our strings. Now when we look at the right-hand side and we add that literal encrypt, we can see one string, but the one that has the lit encrypt, we can't see it anymore. If we grep for it, same type of grep, we just can't see it. That's because it's only going to be viewable when it's run in memory, and then it will be deallocated and back into that state. So it's great for them OpSec perspective right away. Another cool thing I thought is that they give you the native ability with the NT API crate to call direct syscalls. Like rather than calling virtual allocate, you can actually call NT allocate virtual memory. And so when we talk about raw syscalls, which are becoming more and more prevalent as an attack vector or a must-have in your evasion toolkit, they provide that native functionality for you. So you can do some really fun system level shenanigans. This is great, and I completely wanted to talk more about this. I could talk about this hours, but I actually think there's something even cooler that I kind of wanted to talk about and address, which is inline assembly. We've seen a lot, especially in the past few years, about creating your own assembly, your own stubs, your own type of code. And there's a lot of hoops and barriers. Some languages, there's some restrictions, especially when you talk about cross-compiling to Windows. Rust, once again, they've made it easy. They've just allowed for this ability to inline this code to the point where you don't need to even write it in hex. You can just write the human interpreted responses like the jump, XOR, add, you name it, move, R9 to here. You type those things out, and with this inline assembly module, it will translate those into the actual proper opcodes that will then be read on the stack and then properly executed. So here's an example. This is just a simple syscall tool where we're going to mimic NT allocate virtual memory. So if you're unfamiliar, this is the system call that actually allocates memory on the stack. When it's called, it basically takes the instruction with whatever the registries have, move it into the kernel mode to perform that instruction. The kernel then performs it, responds with here's an address, true or false, whether or not it worked. So rather than, having to worry about where the EDRs are hooking this, we can actually just write the same code that we see in a debugger, add our own structure to it, and Rust will go, okay, this is what you want us to do. This is what we're going to do in assembly. Don't worry, you don't have to write the assembly part. So it makes it really easy for anyone to understand and kind of write. So this is one of my favorite parts. I've spent many hours kind of just playing around to see what it can and can't do, and I've yet to stump it. Which is all to say that these are great features, especially from a red teaming, but from a defensive perspective, this is definitely changing the kind of the landscape when we talk about custom loaders or anything else, or roll your own shellcode, roll your own C2. Having Rust with all these functionalities really is going to push that barrier of detection and really make it harder for blue teamers. And I mentioned it at the beginning, so I just want to give it an honorable mention about low-level virtual machines, LLVM. Um, this is just native. Like you don't have to set this up. When you compile, it compiles with this. So this is honestly it just comes default. It's a huge win. It makes my life as someone who's trying to be stealthy easier. But it's basically taking your programmatical code and generating the machine native opcodes for it. So any type of static type of things that we've looked at previously, that's already going to be another additional barrier that they have to kind of detect. And as of a few years ago, when I started looking at this, um, creating standard shellcode loaders where there was no evasion, nothing fancy, no ETW patching or unhooking, you name it, was getting around a lot of security products just because of the LLVM. So having this native has definitely kind of pushed the cat and mouse game back. So I wanted to kind of end this with a simple statement. Rust is awesome. No. What I really want to say is that Rust does balance out the user friendliness with low level technical programming. It has a great amount of elements of different languages that are very popular right now: Python, Go, C++. So if you have a background in that one and are hesitant about learning a new language, don't. You'll find some familiarity and it'll be off to the races. Um, you can do whatever you want with Rust. I have yet to see something that it hasn't been able to tackle. I'm even going to start looking at doing some front end work with it just to see what I can do. Um, the cargo package system is amazing. It's made my life easier, more organized, even if that's possible through all my chaos. And its OpSec features are something that if you're definitely looking at developing and are worried about that, this is a must. So before I kind of wrapped up, I want to kind of talk about a few things. Let's see how is it being used. I talk a lot about it. It's still quite new. But there's a lot of great tools, and I wish I could have just made a huge list. But I figured I wanted to look at a series of different tools from around different aspects. So obviously, Bloodhound is a big tool. We all know about it. If you're unfamiliar, it's a great Active Directory data collector to understand different verticals and laterals of vulnerabilities and ways to move from a low privilege user to a high privilege user in a domain. And someone has taken their time and rewritten in Rust, but there's many other ones, for packet sniffing, TCP hijacking, to Windows rootkits, wireless attack frameworks, even different types of PostX tools. So it's the community is definitely slowly adopting it. GitHub is exploding with Rust tools every day. Um, it's becoming more and more talked about and popular. So I mean, I hope by the end of this, at least one person has said, "I want to start looking at it. I want to start developing." So how do we get started? Well, the first thing someone asked me recently was like, "What's your dev environment?" There's tons of different things that you probably need, like JetBrains or something else like that. How do you pick? And my response is, you don't need any of that stuff. I personally, like I said at the beginning, I just have VS Code, Rust. That's all. If you want, there's some additional modules in like VS Code or other type of languages that allow you to do analyzation of Rust. But it really is that simple to do. Um, as I kind of wind down, I wanted to just kind of say these slides are going to be available, I think, through Deb. And I provided a series of great resources to kind of look at if you wanted to kind of get started down this journey, which I do encourage. There's even a great Rust Lang community on Discord that you can look at. They're great for asking questions, sharing code, knowledge, anything about that. There's great documentation on the different crates and the APIs and everything else to get started. And if you're sitting here going, I wanted to start doing a project in something. I just don't know where to start. Well, I kind of looked through last night and came up with some great packages or crates to look at if you're interested in cloud, terraforming, Windows APIs. So I wanted to kind of just leave these here if you are interested in starting your first packet or your project in some kind of Windows or testing tool or defensive tool. Take a look at these packages. They're highly rated. I've used them all with no issues. So with that, I kind of wanted to say thank you for your time.
Matt, thank you.
Matt, good job, buddy.
Yeah.
Oh, well
Yeah.
done.
And you saved a lot of room for questions. And so
Sure did.
I think today is the room for questions we have. So first, let's get started. Matt, first of all, thank you for sharing your knowledge. And most likely, if you're here today, you wanted to learn about Rust fundamentals. So let Matt know if you would like to learn more about intermediate Rust fundamentals or advanced Rust.
Trying to get him to
features.
create a class. Is that what you're doing?
No.
It might be already in the works. It might be.
Nice.
Yeah, we absolutely like to share our knowledge here at Black Hills.
Mhm.
So is there any community projects we can contribute to?
Oh, there are tons of them. From a pen testing perspective, if you're interested in, there are a couple C2s that are being developed. So there's Oxidize. Any of the ones that I kind of shared as well are looking at definitely. There's one called Arsenal.rs. I think they recently moved it to become archive because the author, his life just got really busy. I think his name is Memops. He has a bunch of great tools, a rootkit and stuff. He's looking for people to help jump on those and just help support it, just because he's created a large swath of tools for offensive purposes, and he just can't keep up with it. So definitely if you start right there, that'd be the easiest one. He's really great at documentation and demos, so you can also reach him in that Discord.
So a quick question for me is why Rust? Like
So,
you gave the whole webcast, but like why? Why did you want to learn Rust?
if anyone knows me, I wrote a bunch of payload tools. I kind of, back in 2020, started going through the whole they're not the great saviors and stuff. Look how easy it is to unhook them and stuff. Slow, unfortunately, to release some blogs, but I released a series of tools that became really popular. If you're familiar with Scarecrow or Freeze, Ivy, and these tools took off by storm. And so when they get really popular, so does the defense. And I spent probably a year of my life just anytime there was detections, I would get flooded on Twitter, social media, GitHub, personal messages. Hey, it's not working anymore. So that was then a week of my life, reverse it, trying to figure out what their detection was, what it was. And after a certain point of this cat and mouse back and forth, I kind of came to the conclusion it was Go. And I actually found a great article where what it was is basically a process that a lot of the Golang communities kind of struggles with is whenever there's a new version of Go, it gets blocked by Windows Defender almost instantly. And they have the process of how to whitelist it. You have to report it to Microsoft, and then they have to look through the package, the main package library to make sure it is, and then they whitelist it or they don't, or you then have to. And I kind of said, well, maybe it's time I look at a new language. And so that was around December of 2021, and I was like, well, everyone's talking about Rust. And I had a friend who was working at CrowdStrike. And he's like, hey, if you're looking for a new project, I highly recommend Rust. He kind of gave me that, we're worried about it without like under the table type of hint. Someone I've known for years and stuff and just knows, like, he always loves hearing those stories I get up to. So he kind of gave me that sort of tidbit. So I started Googling. I was like, wow, Linux is looking to adapt to it. Microsoft's looking. I think I got to take a look at this. And then I started playing around with it, writing my kind of simple loaders. And all of a sudden they're working against EDRs, nothing else. I'm like, oh my God. Oh my God. Like, skin and candy started like Christmas smile. And that's kind of where it all started. And then I haven't stopped talking about it since.
And so most of you don't know. In fact, most people at Black Hills don't know, but Deb and I got a chance to find out that Matt has these notebooks, and that's all we're going to say. And at some point, these notebooks will be webcasts or blogs or something. But there's these mystery notebooks that Matt has that are just, I can't wait for you to figure out what to do with them. Because I think the community will benefit from it. And I think the industry will go like, oh, no. All right, so...
Yes.
Got a couple questions here. Is there a good proxy interceptor similar to Zap, like a man-to-man proxy or burp?
I know there is. I'm just trying to remember the name. I thought did I put that in there? I think it might be Rust Buster. But don't quote me. But there definitely is one. I think a lot of it its GUI is still being developed and stuff. So I mean that's also another great project to jump on. I think it's only about 5 months old. So if you are looking at something like that, definitely take a look. But there are tons of man-in-the-middle fuzzing, directory brute forcing based web app focused Rust tools.
I'm not sure if you know the opposite of this, but let's see. Are there any certain features used in Rust that you see a correlation with detections by EDRs?
So, as of recently, I would say that there's definitely a focus on those compiler flags. We were talking just before the pre-show about free time and stuff. So one of those free times was literally probably a few nights of me creating every permutation of those flags and then passing them to various EDR products to see what was being caught. And the TLDR is a lot of those ones that do like stripping, or when you rip out, like, say, your panic, those ones get caught by security products because you're making your tool lighter, you're removing a lot of junk code, but because of that, you're taking away a big thing that's supposed to be in your Rust package or library or executable code, sorry. And so, like, right there, it's rather to be stealthy, you're kind of drawing way too much attention to yourself.
Here's a question. All right, I got what I need to start with Rust. What resources should I review when releasing it to all our developers?
So from a internal development perspective, that kind of depends on your development life cycle and what is important. I would almost look at some of those articles, definitely in that Discord channel, because there are a lot of developers that share a lot of free content and knowledge about doing something like that, socializing it, and have wide adoption internally. So I kind of go with there. My kind of sort of development is, hey, compiled, it looks good. Someone here at Black Hills, you want to take a look at this before I press the publish button on GitHub and hope that I don't just release a lemon. That's kind of mine. So I don't really have a lot of expertise in that sort of thing, but I do know that there are resources out there to help.
First of all, I would like to congratulate the 3 people who've made it to the Hackit program. They've watched 10 webcasts since we've started keeping track, and you're like, yes. I've been here like 70 times. What are you talking about? We started keeping track 9 weeks ago, right? We had 2 webcasts on one day, and so they got credit for both. But if you're here and you haven't said Hackit yet, let us know. We check each one of them individually, and we give you credit for being here for 10 webcasts. Once you hit 10 webcasts, we're going to figure out something to give you. You actually got there a whole lot faster than we expected. And then we're trying to figure out something to do for when you hit 20 and 30 and 40 and 50, and maybe something for when you hit 100. So we're still figuring that out. And we want to make sure that it goes for a long time. So give us a chance to figure out all the things. So if you are here, say Hackit in the Discord channel. Does it count in Zoom? Nope. It doesn't. Doesn't count.
Just copy it and then paste it into Discord, and then it counts.
And the reason it doesn't work in Zoom is because the goal here is to help you find Discord so that you can find other people to collaborate with, that you can share your common passion for cybersecurity with others, that you can get your questions answered by people in the community, that you can answer questions for others in the community, so that we can all work together to be better together. That's why we want you in Discord. Because the webcast lasts for an hour, but Discord lasts for a long time. All right, Matt, quick question for you. Why
then I'll
Rust?
have a quick answer.
Why Rust? No, just kidding.
You already asked that.
You mentioned a light container to start off in Rust. Name and where?
A light container. So is this the Docker Rust container? I think that's the question. And it's on Docker's GitHub. On the Docker Hub, you just type in Rust. It's like the first one. I usually go by the largest amount of likes and stars if you're looking for a container to code in. But it's very lightweight. I mean, it just literally is a Linux with Rust installed. So if you're looking for something lightweight and something like that, I mean, you can put it on a Raspberry Pi or anything else. But as I kind of mentioned, I literally do a lot of the development sometimes when I'm should be sleeping or something else on an iPad because of how light and easy those Docker containers are.
Yeah. I don't know if you know the answer to this question, but how does Rust protect their software supply chain security?
That I do not have an answer for. I haven't looked into that.
All right. So this is a question that I want you to be very careful in how you answer it, Matt.
I'll try.
Yeah. Just due to the nature of the question, right? We never mentioned clients, things like that.
Yeah.
Have you used Rust in your work with Black Hills?
Yes.
Yes. I feel like we all could have answered that.
Yeah, we'll just skip over the rest.
Yeah, okay.
Yeah, we're safe to say I've used it on client engagements. Yes, it's very effective. It's changed my life.
And theirs.
Sometimes for the worse.
Yeah. And there may, at some point in the future, be a webcast based on what we've learned. So others can learn from
Yes.
that. Okay.
And it might be turned into a class.
Nice.
Now, are there
So-
Rust Easter eggs?
Yeah, that was just what I was curious about
Oh,
too,
yeah,
Jason.
that's a good one.
Yeah. All right, Kelly, you ask.
Well, you just did, Jason. Go ahead.
Take it, Kelly.
So,
Well, let's start out. We've got some new folks on the chat. What's an Easter egg, Matt? And are there any in Rust?
I mean, like, first off, when I think of it, because I've just been talking with a lot of developers, like an Easter egg is a great way to kind of pattern recognize your code. If you're looking for like fuzzing, or if you're trying to add some sort of like shell code, a great example is if you're trying to find your shell code because it's dynamically loaded, you can put an Easter egg, which is a string of characters that are very unique that you can look for, and by looking for that, you can kind of then find where you're trying to go. It's also great for when you're doing type of stack overflow, buffer overflow. As for Rust, I don't know if they come with their own native sort of Easter egg functionality, but it's as simple as kind of creating it. And I'm sure there's a package or a library someone's created. I hope that kind of answers the question. I really hope someone's not asking about actual Easter eggs.
Well, it sort of answered my question because I had a different idea of Easter eggs. So from the non-programmer point of view, an Easter egg is, oh, look at that cool little thing that popped up. Oh, I didn't know that that was in my Microsoft Word application or whatever it was. So from Easter egg, I was thinking more of a line of unexpected, cool programming ooh-ahs that pop up.
So I would say some of those features I described are the cool Easter eggs that I've kind of seen pop up. Definitely like the Python one. That was a pretty big one. I think I shared that around with a lot of our Python developers who just kind of lost their mind. Like, you could put what in what? Like that kind of Russian doll effect or Inception. So I would say that would probably be the big one that I recently discovered for an Easter egg.
Cool.
All right. So Kelly had found another question here. Does Rust have multi-threading, multi-programming, or does it use procedures like Go?
It does multi-threading. There is no procedures like Go. I think that's where it kind of differs and leans more into C and Python, away from Go, to use that example of those three type of languages.
And then Kelly also found this one. Might be covered at some point. How do you obfuscate, protect secret strings in Rust, for example, passwords, tokens, etc.?
From an offensive point of view, if it's in a tool, I would say, some of those literal encryption tools to hide whatever you're doing and store it there. If you're looking at it from, hey, like, LSASS or something like, since Microsoft's slowly adapting to it, that is going to be an interesting question. I think that's going to deep dive into some of the unknown features, but at the very least, I can assume and hope that they implement proper encryption, as well as some kind of obfuscation. There's tons of ones, but depending on how they store it, it can be an issue. Like, obviously, we shouldn't be storing passwords in clear text, so obfuscating those strings shouldn't be an issue if it's encrypted and stored in a protected part of memory.
Well, I know what my afternoon is going to be. Just kidding.
So, Matt, I have another question. If I can spell Rust and I can spell C, does that mean I have high aptitude to learn coding?
Yes. I'll couple that with, if you have the ability to punch that into a web browser or a search engine, then definitely yes.
Okay, awesome.
Nice.
Maybe I'm in for a career change. Oh, I can spell GRC too. So I think I'm talented here.
You got multiple different avenues, multi-talented, jack of all trades.
Matt, as we wrap up here, Travis wants to know, can you auction copies of pages from your notebooks? I don't know. Maybe
I will leave that to you two to decide.
Okay.
How's that sound?
These mystery notebooks. All right, so Matt, as we wrap up, what are your final thoughts, right? If you could sum up this whole webcast into one final closing thought, what would it be?
Rust is awesome. That's like the best way to describe it. I highly recommend you look at it. don't program in Go anymore. No, I'm kidding. I don't want to sound like that. But Rust is really great. I highly recommend it. I'm a big believer that, especially in this field, in this industry, offensive, defense, it doesn't matter. Having the ability to program or develop code, it kind of opens up your mindset. It's almost like I joke with my wife that it's like Sudoku for me, or like the crossword puzzle. Creating little code programs or something like that, it keeps my mind active. So even if you're not using it daily, creating some little cool thing, there's a lot of value and it expands your knowledge. And I think that's really what we're all here to do, is grow and learn.
Mhm.
That's a good point. As we wrap
Well
up, we do these webcasts every single week, right? We have a webcast coming up on GRC with Kelly. Like we have the next couple months just completely mapped out for doing webcasts. Our team loves sharing their knowledge. So we hope that you come back every single Thursday here between 1 and 2 p.m. Eastern time. Show up early for pre-show banter. It is controversial at times.
It's a lot of fun.
It's a
No.
lot of fun.
It's
So
not recorded, so it's
Yeah.
fine.
Yeah, you have to. If you're here, thank you so much for being here. If you're on Discord right now, like stick around, go to the other channels, like see what else is there. This Discord has been around for 4 years, which means if you do the search field, most likely if it's cybersecurity related, it's there. We appreciate you being a part of this community. With that, thank you so much for joining us. Ryan, kill it with fire, Ryan. It is that time. Kill it, Ryan. Kill it.
Kill it. Kill it.